Okay, so if you look at our last session, we mostly concentrated on the git branching strategy, okay, and git merging. How do we do the git branching and how do we do the git merging and all? Okay. Now in today's session, we'll see one more merge type, which is cherry picking. Okay, the word seems to be completely new, but I'll try to explain you what is cherry picking. This is also a merging actually. Actually, if you consider the merging, right, so three ways you can do the merge. If I say merging, right, merging can be done with three commands. One is a git merge, okay, one is a git rebase, and another is a git cherry pick. Okay, each command has its own feature. So when it comes, all of them does the merge. When it comes to the git merge, right, merges all changes, okay, merges all the changes, and creates a merge commit in destination. This is what the typical merge will do. That is the ideal one. Okay. Now, when it comes to rebase, it merges all the changes, okay, and doesn't create any commit, doesn't create any new commit in destination. Okay. Next, this cherry picking. This we did learn in the last session. Now, what is cherry picking is it will merge the given revision number, or you can call it as a SHA-1 sum. Okay, that's it. It will just merge only the given revision number, nothing but. Suppose when you are merging from a branch, okay, like R1 branch to master, okay, so in R1 branch there are like 1 2 3 4 5 6 commits are there. When you do the merge or rebase, all 5 commits will be merged to your master, all of them. Okay, right. Now, but when it comes to cherry picking, if you have a 1 2 3 4 5, right, you can pick up a particular revision number, a particular commit, right, in cherry picking, and you can merge it that into your master. Only one, not all. Okay, so merging a single revision number from one branch to other branch is called a cherry picking. Okay, that's what the difference, right? So git merge, git rebase does the entire merge. Okay, and the difference is git merge will create a new commit and it will not create. But when it comes to the cherry picking, it will merge a given revision number. Again, there's no commit, guys. It's just a revision number. It will be merged. Okay, now how it's gonna merge, we'll see now and with an example. So git pull, already up to date. I'm creating a branch, new branch. Okay, before creating a branch, let me see the log, guys. September 19th is the last date. Okay, the last commit. Now git branch cp, or let me call it a cherry1. The branch name is cherry1, guys. Okay, so git branch, you can see the cherry1 branch is there. Okay, now let's try to check out cherry1. Okay, now I checked out the cherry1 branch. Now let's try to create some files here. Echo hello to cherry.txt. I just created a file, okay, and adding it and committing it in cherry branch. Okay, hyphen added cherry.txt. This is one commit. Okay, if you want me to show it in a diagrammatical way, I can just draw this. Assume like this is master, guys. Okay, so your last revision number is on the 19th. Okay, now what you did it, you created a branch called cp, cherry pick. Okay, cherry pick branch. So in this branch, what you did it, you committed one commit. Okay, you made one commit. Now let me make couple of more commits. So I'm going to delete git rm r2.txt. I'm just deleting this. Okay, now this is going to be another commit, -m deleted r2.txt. Okay, second commit happened. Now let me make one more commit. Okay, echo hi abc.txt. I'm just creating one more file. Okay, git add and make another comment. Added abc.txt. Right. So total how many commits we made it? 3 commits. Now think about master is here. Now master is interested in one of the commit, guys. Any of these 3, not all of them. So master seems to be interested in this commit, the latest commit. Okay. Master wants only this commit to be merged, only that commit, not entire branch, cherry branch. Okay, it just wants this commit. Okay, assume this commit name is C. Okay, and this commit name is B, and this commit name is A. Okay, now master wants C commit. So if you choose git merge or git rebase, right, do you know what will happen when you do the git merge or git rebase? It will merge all 3 commits to the destination, to the master. Okay, right. So if you try to merge the branch back to the master, okay, what will happen? All 3 commits will be merged, but I don't want all 3 commits. I want only a particular commit. So if you wanted to merge a particular commit, then we will use the cherry pick. Okay, so how to use the cherry pick, I'll show you. So for that, first of all, you should get the log. Okay, because with this region number only you can do it. See, 21st September total how many commits, guys? 1, 2, 3. So 3 commits you made now. Among them, I would need this abc.txt, this commit. So try to copy this Shavansan. You don't need to copy entire stuff. You can copy few digits. Okay, minimum 5 to 6 digits, guys. Okay, now get cherry hyphen pick. Okay, right? Don't run it. So now whenever you are merging it, right, I told you clearly you should be in the destination. So where do you want this commit? Into the master. So be there in the master, right? Now in the master, try to run the git log. Master is pretty old, September 19 changes. Okay, so this 4289 is the latest revision number. Now if you do the git cherry hyphen pick, okay, and try to apply, not this, the revision number of the your cherry branch. Okay, let's see. That's it, simple. Git cherry pick. Now you look at this. Can you see abc.txt? It got it now. The reason, if you look at the log also, you'll be knowing it. Can you see September 19th is there, and you got the September 21st single revision number into the log of your master. This is what cherry picking. Guys, did you understand what do you mean by cherry picking? Just getting only one revision number into your branch. Any questions with cherry picking? Sunil, Praveen. This is important. This kind of a picking is not there in the SVN. So people will ask you the questions. Do you know what do you mean by cherry picking? Why do we use it? Simple answer. To get a particular revision number into a destination branch, we use the cherry picking. To get all the changes, all the revisions, we use the either merge or rebase. Okay. Next, stashing. Okay. So what do you mean by stashing is? Okay, I hope you remember this flow diagram. Okay, let me show you. I'll do one thing. I'll try to create a new one. Let's say, Sunil, can you keep yourself in mute?
Yes, sure.
Okay. So I told you this flow diagram in the beginning itself, because without knowing this, you don't understand the git. Okay. So this is what your machine. Your machine. Okay. And this is what your git remote repository. Okay, where it can be a git blit or stash or whatever. We use the Bitbucket. Okay, or it can be like, you know, GitHub, a cloud one, anything it can be. So we are using the git blit at the moment. Now in your workspace, okay, when you create a new file, touch a.txt, when you create a new file, and this file we call as what? Can anyone answer? What do you call this file in the workspace when it is created newly? What do you call that? Important, guys. They will definitely ask these questions. Untracked. Okay, untracked, or you can call it as an unstaged file. Okay, now once you commit it, okay, so with the help of the git commit command, git commit. Sorry, not commit guys, add. Once you add it to your workspace, okay, so what do you call this once you add this file? Staged or tracked file. Okay, right, now it is added to workspace. Okay, now once it is added, then you are eligible to commit it. Okay, now this is what the git commit. Okay, right, now once it is committed, these files are called the committed files. Okay, now this is what your local repository. Okay. Now from here you run a command called git push. Okay, that will push it to your remote repository. Okay, so remember always each and every stage, what do you call, you need to remember, especially the first 3 stages. Okay, whenever you create a new file which is untracked, whenever you add it to your workspace which is called tracked or staged, whenever you push it, commit it to your local repository, it's called a committed. Okay, so once it is pushed to it will be saved in the remote repository. Okay, now the thing is, what I'm trying to explain at the moment is, you go to your git bash. Okay, git checkout master. I'm in a master at the moment. Okay, git status, no changes, everything is good. Let me try to push the data, entire data. Harry. Okay, everything I pushed. Now if you see the git status, clean and green. Okay, git pull, any changes, already up to date. Okay, git status, it's clean guys, it's clean, nothing is there. Okay, now listen to me. What all the files you have it? These are all the files. Let me make some changes. Echo hello some changes to abc.txt. Okay, right, git status, something abc.txt modified. Okay, right, now git add, it was untracked earlier, now it is tracked. Right, at this stage it is untracked, now after adding it is tracked. Okay, so guys, look at this. I have this abc.txt got changed. Okay, I run a stash directly. Okay, now the thing is, before committing in this stage, especially at this stage, you decided I don't want to commit, I wanted to revert the changes. If you want to revert the changes, nothing but you wanted to make it as an original file. Okay, you wanted to remove your new changes, you will run a command called git stash. What it will do, it will revert it back. Okay, now you look at this git status, there's no more change, and you try to display the abc.txt. Do you have the changes, sdf, whatever you typed? So you typed something over, right, it was modified. So you put something into abc.txt which is not there. Okay, so with the help of git stash we can revert the changes. Okay, now with the help of git stash, not only you can revert, suppose, okay, I want to make some more changes guys. Let me make some changes into some other file. Echo hi some changes into hello.txt. I made some changes. You look at the hello.txt, can you see hi some changes here? Okay, now it is in untracked one. Okay, now add it. Right, now it's become tracked. You can see that git status. Right, at this moment I don't want to commit it, I want to revert the changes. If you want to revert it, git stash, that's it. You run the git stash. Now you try to run the git status, it's clean, it's reverted. Earlier I did the abc.txt. Okay, now it's clean, no change. Okay, and you, if you want to hello.txt, do you see that change? Hello some changes? No, it's not there, it reverted actually. If you look at this hello.txt earlier, right, so some changes were there, now it is reverted. Okay, so now how many changes you did it and you reverted? 2 changes, one is abc.txt, one is hello.txt. Okay, in case by mistake if you wanted to have those changes back again, okay, suppose if you want to get all those changes back again, it's really difficult for you to write the code again, because once you revert it, it's gone. Okay, so if you want to get the changes again, right, the git stash will not permanently delete the changes. Okay, instead it will store your changes in some memory. Okay, that memory, you can see this git stash list. Sorry, it is just list, guys. If you do the just list, git stash list, can you see two revision numbers here? Okay, so these are all you actually these two revisions are your changes, actually two changes which you stashed. Actually, if you wanted to get those changes, it's pretty simple. Git stash apply, okay, and try to type the ID of the stash. That's it. Now you look at this, it will apply the change, the latest one, which will be your the most latest one is what? Hello.txt. Okay, so that's it. You got the hello.txt changes back now. Can you see how some changes? This is how you get it back. Okay, you can stash it and you can get it back. Nothing but stash will store it in the memory. Okay, now once you get it back, again same process, git add, blah blah blah. So once it, like if you keep on stashing, right, your list will become such a big list. Okay, so if you wanted to delete from the stash, now you already applied, right, so you don't want this to be here, you can delete it. Git stash delete stash @ 0. Okay, it's a drop, not delete. You might be thinking, how do I know? It's simple, guys. This guy is clearly showing in syntaxes. Git list show drop. I just dropped. 1 second, guys. Give me a second. Guys, nothing stuck. I just took a break for a call. That's it. Nothing else. Okay. So let me continue. So I just dropped the stash, one of the stash. Okay. And after dropping, if you want to check the list, you can run the list command. There will be only one stash. The other one is deleted. Okay, so this is one way of stashing and getting back the change. There is one more way is there. Okay, git stash pop. What do you mean by pop? Is automatically whatever is the latest stash is available, it will just pop it and apply and deletes as well. So the advantage of the pop is it applies and deletes. But earlier one, you need to run a command for apply, you need to run a command for delete. Now you look at this pop. That's it. You got the abc.txt. Did you see this? And also it is dropped your stash. Nothing but it applies and drops. Now no more stashes, empty. Okay, so this is called stashing concept. I know you don't find much useful of this, but Git is provided this feature. These kind of things, we just do it only for the interview purpose. Nobody in the real world performs stashing and all, because developers know it. Okay, they can take a backup of it. It's just about a feature compared to SVN. See, this kind of feature is not there in SVN. So Git, they have to say something new, right? So that's the reason they come up with this feature. Okay, that's called the Git stashing. Yes. So the technical definition of Git stashing is, okay, revert the tracked files, or you can call it as a tracked or staged files, and keep the changes in memory. That's what the git stashing will do it. Okay, if you do the git stash, right? Now to apply a stash, where am I? To apply a stash, git stash, first of all, to see the list of stash. Okay, git stash list, to see the list of stashes. Okay, git stash list. Next, to apply a stash, git stash apply something is there, right? Stash at the rate. Okay, like this. To delete a stash, git stash drop stash 0. Okay, now instead of applying and stashing, apply and delete stash. Both together we do the git stash pop. Okay, but this thing is, it performs only one at a time. That's it. Okay, so this is all about stashing concept. Okay, now similarly there is one more is there. Git clean command. So what exactly git clean is? If you look at the diagram, I'll show you. Suppose you create a new file, guys. Here you create a new file. Okay, so let me add this and commit -n. I'm just clearing the workspace. Okay, git status, and try to push it as well. Git status, it's clean and green, no changes, nothing. Okay, so now at this moment, if I try to create something like uu.txt, okay, git status, can anybody tell me in which state it is there, the uu.txt file? In which state it is there right now? If you want, I can give the options, guys. Is it in a committed? Is it in a stage? Is it in an untracked? 3 options are there.
Designed. Untracked.
Untracked. It clearly says untracked. The reason, I mean, you can read it also. Somewhere you can read it. It's there in the screen itself. Untracked. Okay. So if I told you git stash to clean up the tracked files, nothing but once you add it, you can clean up. Okay. You can revert it. But my question is, can I clean up the untracked files or unstaged files? Okay. So for that, we will use a command called git clean. Okay. -f. That's it. Removing a u. Can you see this? Removing the u.txt. Now you run the git status command. That's it. It's clean. So a command called git clean will be used to clean up the untracked files. Git clean -f. Okay. Use the -f option to clean the untracked files. That's it. That's what the git clean. Git clean -f. Okay. And you might be thinking, can I get it back like a stash? No, impossible. Okay, there is no reverting. Okay, I mean no backup maintain like a stash. In stash it maintains something in the memory, but in git clean it doesn't maintain anything. Okay, so these are all okay. You might be thinking, can I revert from here? Okay, so once you committed, guys, you can revert it, but it is dangerous to revert it because you have to change your latest revision number. Okay, head revision number. Okay, so for that we use a command called git reset head -1. What do you mean by nothing but you will remove that commit and you go back one commit back. Head is nothing but latest revision number. This -1 nothing but one revision number back. Okay, -2 nothing but 2 revision numbers back. Like if I show it in your master copy, like if you see, this is what your master, guys, this line. Okay, you made couple of okay, many commits are there. Now you made one commit, this commit. Okay, now if you don't want this commit to be there in your local repository, if you don't want this, right, you have, I mean, right now the head is pointing to your this commit. The head is here now. Okay, head revision number, right? If you wanted to go back to this revision number, if you want to go back to this revision number, you need to use git reset head -1. If you wanted to go back to this revision number, you have to use git reset head -2. But always doing this is not a recommended approach. Nobody does. If you want to clean up something, you do it in your these two stages only. Once you committed, if you want to revert it, right, you manually revert it, okay, and you commit one more. I mean, you try to commit one more. There's no problem in it. You have a history, okay, but don't try to delete a commit from the history. It's not recommended approach. You can do it without. If somebody asks a question, is it possible or not? Yes, it is possible, but it is not recommended to do that. It will screw up your entire history, okay. So you will definitely face some challenges later, okay. So because what happens, you know, I'll show you the diagram now. What happens if you try to go back, okay. So if you try to go back, right, now your pointer is at here, okay. Now the master continues like this. Master will be continuing something like this. Like you start working like this, okay. Now what happened, this part, this becomes an orphan, okay. By mistake, tomorrow if somebody, like, you know, check out this revision number, because this will be lying in the git. It will never be deleted from the git. The revision number will be there in the git, okay. If anybody, like, you know, checks out so this revision number and tries to push it, okay, they tries to push this one, right, it will unnecessarily becomes so much of complex to your version controlling system, okay. So that's the reason, I mean, resetting the revision numbers is not a good idea to work in the git, okay. So but you can do it. There is a possibility is there, okay. So why the possibility is there? I'll tell you one reason. Some naughty guy committed a 5 GB file in this revision number. You know, if you commit a 5 GB file in the revision number, every time when you check out, the performance of your git repository will be drastically comes down, okay. If you wanted to, like, you know, remove that revision, this is the only way. At least in git there is a way to, like, you know, go back, okay, but in SVN there is no other way, guys, okay. You cannot do that at all, okay. I hope you understand now what you, like, you know, git clean and git reset and all, okay. If you want, I can show you the git reset -1. So git log, you look at the latest log. What is the latest log, guys? This is what is your latest revision number. See, whatever you see the topmost, this is what your latest revision number, okay. Copy this, okay, right. Now what I will do, git reset head -1, okay. Now can you see, now you look at the log, git log. Did you see that 2-1? No, it's gone. It is lying now, okay. So that's the reason. Now I mean, if you start continuing it, it's okay, you can continue, but the thing is, tomorrow if somebody, like, you know, gets the revision number, it screws up your repository, okay. So that's about git clean. Now let's move on to the packages, okay. Now packages, now come back to your this one, okay.
Can you commit it again?
Which one?
Same file. That's
it is there, yeah. The files are there with you. Can you see this hello.txt? They become untracked now. See, when you remove that, right, okay, the files will become untracked. If you want, you can commit it again.
Oh, okay.
Okay. So
Okay.
now the packages, okay. What do you mean by packages is, see, I'll give you one more scenario. Let me extend this diagram itself. Treat, he is a developer A, dev A, okay, and there is one more developer is there here. Is one more developer, dev B, okay, right. So dev B is a newbie, nothing but is a kind of a fresher, okay, right. So what he is doing it in his local repository. This is what his local repository. Now what he did it from his workspace. He made 3 commits. 3 commits he made to his local repository, okay. So total 3 commits are there. Now these 3 commits he's about to push, about nothing but he is ready to push to the remote repository. But before pushing it to the remote repository, what he wants is these 3 commits, whatever the 3 commits are there, okay, these 3 commits he wants to be reviewed by his team lead, and this team lead is this guy, okay. Now in these 3 commits he made so many changes. Okay, so how do you think he can review it? Okay, either this guy is supposed to come to this guy's laptop and view the code. Okay, if that is the case, right, think about this developer A is a team lead for 200 people. Okay, do you want this guy to go to each and every guy's desk, or think about this guy is there in different geographical area and this guy is different geographical area, so it's going to be really tough for him to review the commits. Okay, so instead of that, Git is providing a way where what you can do, you can create, you can zip these 3 commits and you can send it to him through email or through a file system sharing or whatever. Okay, you can send it to him, and a developer, what he will do it, those 3 commits he will apply on his workspace and he can review it. Okay, and sending these 3 commits to this. Okay, and these 3 commits we make it in a format of a packages. Okay, we create the packages of these 3 commits. So every commit is one package. Okay, we create 3 packages, we send it to the developer A, and this guy will apply the packages on his workspace and he reviews it and he say okay, if the package, the changes are good, he say yes, then this guy can push it. Okay, so that's what the packages meaning. So let me try to show you by example, then you'll understand much better. Okay, now let's clean up this one. Okay, I just wanted to clean up this. Git pull. Your local changes to the following files to be overridden by merge. Git clean. I'm just cleaning up my changes. Now git pull. Git status, it's clean. Git pull. Okay, git log. Now if you just pull it right without pushing it, you will get your changes back. Okay, now I got my latest change number is back. Good. Now git status, everything is clean and green. Okay guys, now I'm making some changes. 3 commits I'm making it on master. Okay, echo git add, this is what my first commit, git commit modified abc.txt. okay, so packages example, right? One commit is done guys. Let me make one more commit. I'm just making 3 commits. -m modified hello.txt for packages example, right? I'm making one more commit, third commit. Okay, git rm, I'm just get, I'm deleting some file here. Okay, now git commit -m delete release1.txt for packages example. Okay, look at the log. You made 3 commits. As I said, I made 3 commits. Okay, now I'm a fresher, I don't know whether I'm good to push these changes or not. Okay, before pushing, I want these changes to be reviewed by my team lead. Okay, now how do you send my changes to my team lead? Okay, now to send your changes to your team lead, what you can do, you can say git format patch. Okay, now when you do the git format patch, you check it out. Sorry guys, the command is wrong, something just forgot the command. Where is it? Docs caret git part 2. I already sent this doc to you, you can just look into it. The package is going to be the last concept one. Where is it? Patch. Yeah, format patch, you have to provide your branch name. Sorry, the command is correct, only thing is you have to provide your branch name. Okay, or is in master, because I'm doing the master. If you wanted to do it on the year, because you know what, commits are specific to branches, that's the reason branch name is mandatory here. If you do the commits in R1 branch, it will not create a package here in the master. You have to give the R1 branch name. Look at this. It's not status. Format patch. Right, guys, did you see 3 packages are created now? Okay, 001, 002, 003. So if you look at 3 zip files are created, some sort of a zip files for you. Okay, so 3 zip files are created. Now what you're supposed to do it, give these 3 zip files to your team lead. Okay, whoever it is. Now git practice September. Can you see this? These 3? These are the packages. Now these 3 packages, give it to your team lead, then that guy will try to apply and see the changes. Okay. Now let me create one more workspace for my team lead. Okay. Actually, it should be a different machine. You should share it through some medium. Now let me try to git clone. Try to clone. Okay, repo.git. It's already there. Repo 1. Okay, I just cloned in the repo 1, guys. That's it, nothing else. Okay, now git status. Look at this. This guy has a release1.txt file, and if you look at the cat abc.txt file, it is having hi, hello and all. And if you look at the hello.txt file, and it is having these many changes. Okay, but if you see the packages, whatever this guy is having, okay, he modified abc.txt, he modified hello.txt, he deleted this file. Okay, now try to get all these things into your team lead workspace. Ask him to copy them to his workspace. Okay, now what is supposed to do it, git patch apply 00. Okay, let's do one thing. Let's apply the first one. Okay, which is abc.txt changes. Okay, git patch. Okay, not there is no patch, guys. Git, just say git apply. Right. So now you try to run the abc.txt. Guys, can you see this? Only one line answer, because that guy updated with only 1 line. Okay, earlier it was how much? These many lines are there. Okay, so that's abc.txt. You can look at the abc.txt is having 2 lines. Now it is only 1 line. Okay, now you applied the first patch. Now similarly you can apply the other patches. Git apply 002. 2 is what? Update the hello.txt. Now you look at the cat hello.txt, you have only this change. Okay, and originally what all the changes are there? These many changes are there. Okay, now the next thing is the last patch. Guys, you have a now release1.txt, right? Okay, if you look at the last patch, this patch, git apply 003. Okay, it should delete the release1.txt. Okay, now you do the ls. Did you see release1.txt? It's gone. So this is called packages. Sorry, patch sets, guys, not packages. I gave a wrong name, but the concept is same. It's a patch sets. Okay, not packages. Did I mention packages anyway? It's a patch sets. Okay, so I created 3 patch sets in my machine. I mean 3 patch sets, nothing but 3 commits. Every commit is 1 patch set. Okay, remove this. It's not package, it's a patch set. Okay, so every commit is a 1 patch set, and I given all 3 patch sets to this guy, and this guy applied and he verified. If he feels good, he says okay, everything is fine, then he will say go ahead, then this guy can push it. Now this guy can push it to remote repository, so that in the remote repository you have a proper code. Okay, so this is called patch sets concept. Did you understand, guys, what do you mean by patch set? Did you understand the patch sets?
Yes.
Okay, so remember one thing, patch sets can be created only for unpushed commits. Unpushed, nothing but, look at this now, come back to your original repository. Okay, now if I do the git push Harry, okay, now you try to delete the existing patch sets, rm the untracked file. Okay, you can say just say git clean -f. Right, now guys, there are no changes, everything I have pushed. Okay, so if you try to run this command format patch origin master. If there are no commits, you made it. Everything you pushed it. Now you pushed everything. There is no commits. If you try to run this command, this will not create any path sets. If you want, you can cross check it. No path set is created. Okay. The path sets will be created only for the unpushed commands. Okay. You shouldn't push those commits to your repository. Okay. This is all about the path sets. Okay. So let's try to come back to the server side. Server side. Okay. Server side mostly access control job which you do it, and access control which I already explained in the beginning of the session when I install the git build. Okay, so access control is nothing. Go to the users, create all the users, give the access to the repositories. It's pretty simple job in the git. It's not like in SVN. Okay, now the second thing is backups of repositories. How do you take the backup of the repository? Okay, especially with the git, right? There's nothing like a concept of zipping your repository. Okay, every developer has a full repository. You understand, right? See, in SVN, people could able to get a single branch, R1 branch, R2 branch and all. But in Git, did anybody could able to, like, single branch? No, right? Entire repository, they cloned it. Okay. So everybody has a backup. But that doesn't mean, like, you shouldn't take the backup, but you have to take the backup. So to take the backup, right, go to your server. So I have set up the server in my Windows, right? So you go to where exactly you set up. So where is my git build? This is what git build. You can find a folder called data. Inside the git, can you see repo.git backup repository here? Now your job is to just zip this, okay? Zip it with, like, whatever the way, okay? And keep it somewhere, okay? So just take a backup of it. If you have it, you have a source code. That's it, okay? It's pretty simple. So if you want, you can reproduce your code at any point of time, okay? Assume, guys, you lost your Bitbucket server, okay, and you set up a completely new repository, new setup, okay? Now I'll just show you, like, how to reproduce the new repository, okay? So let's try to create a new repository. Treat it like, this is a brand new Bitbucket git build for you. New repo, recovering the repo, okay? Recovering the repo. So don't include any readmes when you're recovering it. Okay, it should be empty one. Okay, now it is the empty repository, right? Take this copy. Okay, now come back to your existing. So somebody has the backup of the original repository repo. It is not repo new. Okay, now what you can do it, get remote add origin recover RC. You can give something origin 2 whatever. Okay, add and try to provide the new repository path. Harry, right? Now you look at the git remote -v. Now this origin is the original one. This is now gone. It's crashed. There's no more server. Okay. Now you added the origin 2. Now what you can do it, do your entire data git push. Okay. Origin 2. Harry. Okay. I think this guy doesn't have access. So we should first provide an access to this guy. Go to the users. Okay, once you create a new repository, make sure, see, only for repo it is there, not for new repo. For new repo also try to provide him the full access. Okay, save it. Now you try to run this command. That's it. Now you go back to your new repository. Guys, did you see the entire history now in the new repo? This is new repo. Okay, entire data is there from last 2 days. So this is how you can recover it back even if you lost your git build repo. It's pretty easy in the git compared to SVN. In SVN you have to make a dump file, load it by creating a new repository. It's pretty easy here. You just add a remote agent and you can do it. Not only this, somebody said, like, migrate your repository from git build to GitHub. Okay, I'll show you how to migrate to GitHub. It's a pretty simple job. To go to GitHub. Okay, register. I'm already logged in here. Okay, let's try to create a new repository. New repo. Let me say new September repo. Okay, this is what my new September repo is. Okay, so some test, right? Don't include any readme, just create a repository. Right, now you have a repository, right? It's an empty repository, no code, nothing is there. Okay, so copy this URL. Okay, now come to your whatever the code base you have it, same commands as it is, git remote add, okay, origin 3, provide your URL, right? Now git remote -v. Now you see 3 repositories pointing to this one. Okay, now you can push git push origin 3. Username is my email ID, guys, especially for the GitHub, gmail.com, and a password, my password. That's it. It's pushed now. Now guys, you refresh in the GitHub, you will get entire data. Can you see this data? R1, R2 and all blah blah blah. Today's data. This is what your data. Okay, and you have branch as well, one master branch, only one branch is there. Okay, and you can see your issues are there, right? So you click on it, you can see your source code, and you can see your commits as well. Somewhere you can find commits here, 26 commits. Did you see this? Delete releases on .txt. Pretty easy to do, migrate from your local to here. This is on 18th commits, these are 19th commits, these are today's commits. Okay, so guys, did you feel do you have any questions with this migrating from on-premises to GitHub cloud? Any questions still here?
No questions.
Okay, fine. Thanks so much, guys. So we can wind up the Git now. That's all with the Git. Okay, so nothing more about it. So if you first practice whatever I explained, and apart from that, if you get any more questions, you get back to me. I'll try to help you out. Okay, so I'll try to give an introduction and just stop the session of the build process automation so that we can continue tomorrow. Okay, so the next topic is going to be, so as per our agenda, we need to cover version controlling systems first. Okay, and we covered both the tools, and we need to cover the build process automation. Okay, the next deployment automation. Okay, not deployment, continuous integration. Okay, so we just completed one topic. Okay, this is a bigger topic. Don't think like only one topic. It's really such a bigger one. SVN and the Git. Okay, now let's come into the build process automation, guys. Okay, so in build process automation, especially, this is another important responsibility of a build engineer or a DevOps engineer who does the source code build. Okay, especially when it comes to build. Okay, just listen the word build. Build nothing but what? You prepare something. Okay, something useful. Okay, so in a software world, especially in the work which we do it, okay, in our world, the build nothing but it contains compiling the code, okay, running the unit test, okay, packaging the code. Okay, so typically these are all the steps will be there in the build. Okay, so somebody, a layman, can ask like, what do you mean by compiling? I know few guys might not be knowing what do you mean by compilation if you're a non-IT guy. Okay, so what do you mean by compilation is? Compiling or compilation is, see, all the programming languages which are written by typical developers, your C, C++, Java and all. Okay, these are all human readable languages. Okay, human readable languages, nothing but they can write the code in there, because the C, Java and all, the developers can understand what it is. Okay, but your computer, your processor don't understand your human readable language. It requires a binary language. Okay, it requires a binary language, right? So, but a human being cannot write a binary language. It's really tough for him. Okay, so that's where you would need a software, okay, some medium, okay, okay, which converts a human readable language into a binary language by checking all the syntaxes, nothing but the rules and regulations of how you're writing it. Okay, there should be some, if I say like our language, right, if you're writing some sentence in English, nothing but you have to follow the grammar. Okay, so similarly for your source code, you're also having some grammar. So whoever is writing the code, they have to follow the grammar and write the proper code. Then only your medium can convert the code into the binary. Okay, this medium in programming language, we call it as a compiler. Okay, right. If you get any grammar mistake, okay, that is called syntax errors in programming language. Okay, so if you write anything wrong in your human readable language file, okay, which is C, Java, it can be anything, those errors called as syntax errors. Okay, syntax or semantic errors. Okay, now if you clear all the syntax and semantic errors, your compiler, okay, will provide a binary file which can be executable by your processor. Okay, and this process we call as the build, okay, or compilation. This process we call as a compilation. This is a compiler, and this code will be converted to the binary language, and this process we call it as a compilation. Okay, this process we call as a compilation. Right, so just by compilation we are not done, okay, because what happens, you know, you have 100 source files, okay, 100 source files, nothing but human readable language files, okay, the 100 programs are 100 source files, okay, these you compile it, okay, your compiler will create what, 100 binary files, okay. See, this 100 binary files you cannot run by one, okay, so you may want to run all together, but it's not possible to run all together depending on the platform of, like, you know, what programming language you are running it. Okay, so what we can do it in programming language, we have another feature called packaging. Nothing but you zip all 100 files together, one main file, that's it. Okay, one main file. So this main file can be executable by on your system. So this main file called a one binary file. So instead of having 100 binary files, after packaging we prepare one main file. So guys, you might download so many softwares. Look at this, you download Putty, you download Vagrant. Do you think Vagrant is a single file? You try to zip it with any of the archive file, right? It has n number of files. Can you see? These are all the files. Can you run? These are all one by one. Impossible. So you package it with a single file. That's called a packaging. Okay, right. Now this step covered over here. Okay, I'm just putting. Apart from this, there is a concept of unit testing. This is a new concept in the modern software development, where what happens, you have 100 source code files, okay, you compile all of them, right? Now before packaging it, okay, we can run some unit test. Okay, I'll explain you this unit test in the when I'm talking about Maven tool, guys. At the moment you understand unit test is something like, you know, a small code written by developer itself, okay, and that will execute against his code and give some results. Okay, right, so this will have a status of success or failure, that's it, nothing else. Okay, if it is success, you package it. If it is failure, don't package it. Okay, so that's the state. I cannot give more information over here because I need to explain a little bit more about it. Okay, so at the moment you understand this unit test is modern software development practice. People are writing it, and remember one thing, this is optional, nothing but without the unit test also your build can be completed. Okay, it can be completed. Now all these three steps together, compilation, running the unit test, and packaging, all together we call as the build process. Okay, all together we call it the build process, right? Now did you understand? Now you should understand the word build process. A build process, nothing but a source code compilation, a source code packaging, a source code unit test execution, together we call it the build process. Okay, so earlier days, maybe like, you know, 10-15 years before, the developers used to do, or like, you know, who are assigned to this job, they used to do this process manually. Okay, manually, nothing but they have to do it through either through Eclipse or through, like, you know, from command prompt, right? So if you're the developer, he does through Eclipse. Typically for Java it is Eclipse, for a .NET it is a Visual Studio. So those are called the IDEs, interactive development environments. Okay, some software, see, IDE, nothing but nothing, guys. To type this code, what I'm using, Notepad++. This Notepad++ is IDE. Okay, similarly to write a Java code, we have Eclipse, kind of Eclipse is there. That's one of the popular tool to write the Java code. Okay, for .NET code, Visual Studio. So developers does through that. But when it comes to ops guy, DevOps guy, or a build engineer, we need to do it through command prompt, because we do it on the Linux machine, right? So we need to do it in the command prompt. So using command prompt, how do you compile a code? How do you package a code? How do you run the unit test? So these are all the steps. There are n number of steps are there. N number of steps. Okay, n number of, nothing but, suppose there are 5 steps, guys. Okay, now 5 steps, you may need to do it every day 10 times. Okay, think about, there are 20 projects are there, guys. What is the count now? How many times you need to repeat? 10 into 5, 50, 50 into 20, 10. So 1000 times, right? 1000 times you have to perform this thing. Suppose each time 5 steps will take 30 minutes. Will take 30 minutes. Okay, so think about, like, count it, how long it will take it. So it's a completely time consuming process. Time consuming process. Okay, it's difficult to, like, perform manually. So as it is really difficult to perform manually, that's the reason we would need to automate this process. Okay, so with the automation process, with automation, okay, it should complete in seconds or minutes. That's without manual intervention. Okay, so first of all, before proceeding the automation, right, I will show you how to do it manually. Okay, because without knowing it manually, no point in, like, going to the automation. Okay, so for that, let me take a simple example. Okay guys, I'm going to choose Java as our platform for build automation. Okay, Java as our platform for build automation. Okay, now, so I need some source file, human readable language source file. Okay, so let's try to take this human readable language source file uh, and open a new file and try to save this. I'm creating a new folder. Okay, and try to create a folder called source src. So inside this, save it with a name called hello world. Whatever the class name is there, this is a Java standard. Okay, and try to save it with the double quotes, otherwise it will not take the extensions. Right, now this is a simple Java program, guys. This Java program prints hello world on the console, nothing else it will do it, and you don't need to know the Java language also. Okay, don't worry about it. This is written by a developer, so this is the code given by developer to you. Okay, now how do you perform all these steps whatever I mentioned here? See, I have mentioned something, right? You have to compile, you have to, like, run the unit test, you have to package it. Okay, how do you perform all of them? So remember, if you choose your Java as a platform, first and foremost you need to perform some prerequisites. Okay, prerequisite installations. Okay, so you should have JDK software needs to be installed. JDK nothing but Java Development Kit. If you want, you can Google it, you can get that. Okay, JDK download. It will take you to the Oracle site. Okay, now guys, can you see this JDK download? So you click on this, it will give you which operating system you are using at the moment. Accept if it is a Linux or Windows 64, 34. So it's a 188 MB something. Okay, download this exe, guys. All of you, please download this exe before tomorrow's session. Okay, download this and double click next. It's a simple installation, Windows installation. Okay, do it on your Windows only. Okay, because this we will do it on Windows itself. Okay, so try to run this, and once it is done, okay, in your operating system you have a JDK software installed. Okay, this JDK contains compiler, guys. Okay, the compiler software it contains, plus it contains runtime environment. Okay, right, so it contains packaging tool, it contains all of them actually. Just a second, guys. Sorry guys, so this JDK software contains all the tools which you need, because I'm saying compiling, running, what do you call it? Packaging, right? How do you do that without your operating system supporting? So the JDK software will install all these tools so that you can perform your code compilation, code packaging, code running, all of them. Okay, so make sure you install it. I have already installed in my machine. I don't want to show the typical Windows installation. Okay, so once your JDK is installed, you just cross check with this command whether your JDK is there or not. So it will show you Java version 1.7 dot something, for you 1.8 dot something, because it's the 8th version is the latest. Okay, so once it is there, you have all the software is installed, guys. Okay, now once all are installed, what you're supposed to do it, the first step, okay, you have your source file hello world.txt, hello world.java, okay, in some folder. Okay, now you need to compile it. So to compile it, guys, please follow these instructions. Pretty easy. Somebody provide these instructions so you can easily follow. So you have to use a command called javac. This javac is called as the compiler actually. Okay, the compiler is represented as the javac command in Windows or Linux, which are the operating system. Once install the JDK. Okay, if you want, you can cross check. If javac command works, your compiler is there. Can you see it is working? Nice. And if Java command is working, then your runtime environment is there. If jar is working, your packaging tool is there. So this is a symbol, like, whether the required tools are installed in your machine or not. Okay, now let's try to create this directory. This guy is asking to create a directory, because if you look at the directory over here, and practice September, okay, src is there. So once the code is compiled, you wanted to, like, store the binary file into some other folder. So that's some other folder I'm creating now. Okay, build classes. Okay, so if you wanted to store this hello world.java binary file into some other location, I just created this. Guys, this is optional. If you want, you can store there itself. Okay, but this guy is following the proper standard. Now try to copy this command and go to the command prompt, and you need to go to the directory where you created your src folder. Okay, here. Now try to perform this command. While performing it, guys, remove this OAT. I think I need to remove from here as well. Okay, it's already removed. So source path, what is your source code path? src -d, nothing but destination. You already created build classes, and you need to provide src your main class name. That's it. It's compiled successfully, guys. If you want, you can cross check it. Can you see hello world.class file? A binary file is created, and this binary file, you don't understand anything. This is understood by your runtime environment, your processor. Okay, now if you do any grammar mistake, like, syntax errors, you remove this curly brace. Okay, now you try to do the compile. Can you see this? Expected this curly braces, that's called error, and these errors we call as the compilation errors. Okay, so you need to, like, follow the proper syntaxes, then only the code will be compiled properly. Okay, this is called compilation, right? Now similarly, packaging is also there. Okay, java jar, this is what packaging is. I'm not showing the unit test, guys. Right now unit tests are not there in here. Okay, so you need to create a package, but before creating a package, you need to create a manifest file, because I'll tell you why manifest file is there, but let me try to show you the package first. Just look at this command. Okay, this command will create a package in build jar. Okay, do you have a build jar directory? I don't think we have a jar directory. Let me try to create a build jar directory here. Make sure you have the directory, jar directory. Okay, now inside the jar it's empty. Now inside the jar, I'm going to create a hello world.jar. Okay, you might be thinking why you are packaging. You only have one file, right? See, now it is one file. Tomorrow there can be 100 files. Okay, so that's the reason the command is same for one file or 100 files. So -c build classes, you have to provide your classes folder directory, not one file. I'm just providing the folder directory. So if you provide that, what all the .class files are there here, it will zip everything. Right now it's zipped successfully. If you want, you can cross check it. Can you see hello world.jar file? Okay, so once the jar file is created, now you want to test whether this jar can be executable or not. So to execute your jar file, try to run this command -jar build jar hello world.jar. Is it executing? No, actually it is showing something, some information, no main manifest attribute. The reason why it is showing, because whenever you are creating a jar file, right, and if you want to execute a jar file, okay, you have to include a manifest file. Okay, the manifest file is mandatory. So that manifest file contains Nothing. It contains the main class name. It's pretty simple thing. See this. You try to run this command. This will create a manifest file for you. That's it. Okay. Now you go back to your this. Can you see main class? Remove the OAT. My main class is only hello world at the moment. Okay. So try to create that manifest file. So once that manifest file is created, now your jar command is there, right? Try to create the jar one more time. In this jar command, you have to provide an option called M and my manifest. That's it. Now the jar is created now. Okay. Now to check whether this jar is working or not, can you see hello world guys output? Now it is executing this. This is what the output I need it. Okay. Now it is executing properly. So this is how you perform the build, a compilation, packaging, all of them. Okay. And this entire process we call it as a build process. Okay. Right. Now I told you theoretically, now we are seeing this practically as well. Okay. The entire process we call as a build process. Okay. And this build process, whatever you do at the moment is manual. Everything is command based. Okay. But think about to perform this itself, you spend something like 5 to 10 minutes. A simple hello world Java file to compile, package and all. You spend almost 5 to 10 minutes. Okay. So think about tomorrow you have hundred thousands of Java files. Okay. And those kind of 10-20 projects. Okay. And somebody asked do it every day 5 times each project. So it's going to be too difficult to remember all these commands. Okay. And there might be first problem is manual build disadvantages. Okay. Or manual build issues. The first and foremost important is the time consuming. Okay. It takes so much of time. And second thing is no quality, nothing. But see, now you're running the commands properly for first build, second build you do it, third build, fourth build. Okay. If you keep on doing the monotonous task, right, you may try to miss some characters, miss some option. Okay. That will give you wrong builds. Okay. And that may cause the problems later. And the thing is maintainability, maintenance. Okay. Maintaining these many commands is really tough. For single project is okay. There are hundreds of projects there. For every project you have to remove maintain all these commands, and also that is also a big problem for us. Okay. So to avoid all these manual build issues, okay, the management or the teams expects we need somebody to automate the build process automation. This is called build process automation. So they want automation. Okay. They don't want anything to be done by manually. Okay. What exactly they're expecting is we wanted to do, we just do a enter button, we just enter, it will perform everything, entire build process. Or we just want to do a mouse click. Okay. That should take care of everything, and this should be automated everything. Okay. So that is what the expectation from the industry, and the DevOps guys or the build engineers or whoever is responsible for this job, you need to automate this process. Okay. So to automate this process, you cannot automate that easily, but in the market there are tools available to automate it. So Apache Ant is one tool, Apache Maven is one tool, Apache Gradle, all are from Apache only. Okay. So these are all the tools to automate the Java projects, guys. Okay. These are all for the Java. Okay. So similarly you may get a chance to work in .NET as well. Who knows? Okay. So when it comes to .NET, is MS Build is one, Enant is one. Okay. And you may work on C++ also. Who knows? That's the reason it is a platform specific. The build process automation is a platform specific. Okay. So we are working with the Java. Tomorrow it can be like .NET or C++. So it's a make, CMake, break. Okay. So these kind of what do you call, tools available for .NET and C++. We are not concentrating much this because the majority of the market is with Ant, Maven, Gradle and all. Okay. But as part of our training, I'm going to cover Ant and Maven, guys. Okay. So tomorrow we will start with Ant first. Okay. Ant. Right, guys. Any questions with introduction of the build process automation? Any questions? Did you get it? What do you mean by build process? What do you mean by build process automation? What is a build? Guys, did you clear enough? If you have any question, you can ask me. All of you. Sunil, Praveen. No questions. That's good. Cool. So thanks so much, guys. We'll catch up tomorrow. We'll continue the session tomorrow. Tomorrow's session will be interesting. You have to write some XML coding and all. Okay. So please be on time. We'll catch you tomorrow. Thank you, guys. See you all.